Well, children, you have already seen rational numbers, irrational numbers, and you have marked them on real number lines and graphs. All these activities are done. Now, we are going to a new concept called real numbers and their decimal expansion. Real numbers and their decimal expansions. Nothing. A number can be expressed as integers. There is no problem. Like if you have 3, you write it as 3. No change. There is only one way we can express it in a real number system. Whereas fractional numbers, rational numbers, like for example, if you take 1 by 2, either you can write it in a fraction form 1 by 2, or you can write it as a form 0.5. So there are two ways we can express things. So decimal expansion. So looking at the decimals, how can we say, and what are the various techniques that we use while converting a number into from fraction form into a decimal form? Let us see. And decimals basically, for example, can be of three ways. Like for example, some 0.23, 0.234. If you want even 2, 3, 4, 5, just like that. So a decimal that is ending after some 2, 3 places, it will stop. And there are other ways where decimals will not end. For example, 0.3, 3, 3, 3, 3, so on. 3 will be coming and will not stop at all. So this decimal is not ending. And so generally we write them as 0.3 bar. Similarly, there may be 2 digits repeating, 24, 24, 24, 24. So naturally we will write it as 0.24, 2 and 4 repeating. So like this, there may be decimals which are ending, decimals which are not ending. There can be one more way also, like 0.13472. It is like there will not be any pattern, any repetition. 7, 9, 2, 4, like that randomly they will be repeating. So now let us see, randomly one after another numbers will be coming. So let us see. Now if you basically observe, here is the first category where decimal will end maybe after 1 place or 2 places or 3 places or 4 places, that are some 5 places. Sometimes decimals will end. A fraction, if you are writing into decimal, it will end. And the other cases are where the decimals are not ending. There are 2 cases. One case is like a same digit will be repeating again and again, so we write them using bars. This is the non-terminating and repeating. And there will be another model where number will not be repeating, there will not be any pattern, simply randomly they will be repeating. So these are mainly the 2 types. Let's rewind them. So basically 2 types, terminating and non-terminating. So what is this terminating? Let us say take some fraction 1 by 2. If you write it in decimal form, like for example 1 you are dividing with 2, 2 zeros are 0, means zeros are 0 will be less. So naturally we will take a decimal and we will take a point. Now 2 5s are 10. So what we get answer here is 0.5. This is terminating decimal. Now if you take 1 by 4, like 4 with 4 you are dividing 1. So 0 you are taking. 4 2s are 8. So 2. So since decimal is there, we can take one more 0. 4 5s are 20. So the division is done. What is the value we are getting? 0.25. So 1 by 4 is equal to 0.25. See, for example, in this case, after decimal only one place we got. When we are writing a rational number in form of decimal, here after decimal we are getting one place. Whereas here in the after decimal we are getting 2 places. Like this, there may be 1 place, 2 place, 3 places, but somewhere it is ending. These things we are calling as terminating decimals. Whereas non-terminating decimals, let us take an example, 1 by 3. 1 by 3. Now with the 3 you divide 1. Since 1 doesn't come, 0 point, so 0. 3 3s are 9. What is left out? 1 again. 0 again, since because of decimal. 3 3s are 9. Again 1. Again 0. 3 3s are 9. So this will be coming 0.333333. So 1 by 3 is 0.333. So simply, so on, same 3 will be repeating. So we call it 0.3 bar. Similarly, if some decimals when you are dividing, you may get a bigger one. These things we call as non-terminating and repeating. Non-terminating, repeating. Whereas some examples, as I told you, 1 2 randomly you write something 5 4 1 3 something like that. They'll be continuously going on. What जो मन में आया वो लिखते जाओ. So these numbers are also non-terminating, but there is no pattern there, so we cannot write using bars like this. So no, non-terminating, non-repeating. So these are the two basic models, basic ways, three basic ways we write a decimal. Now in the next chapter they'll be asking you some questions about like regarding these decimals. For example, they'll ask you 1 by 7. So 1 by 7, let's see this. Let us see this 1 by 7. In 1 by 7, you can see here like 1 decimal they have taken 1. 7 ones are 7. So what is left out? 3. Again because of decimal 10, 0. 7 fours are 28. Then 7 twos are 14, 7 eights are 56, 7 fives are like this. So the what finally are we getting here is 1 by 7 is equal to 0.142857. Do you know why he has stopped doing division? You can even go here also. Here also you can take another 0 and you can repeat. But he has stopped because he came to the point where he has started with. He has started with 1 and again he got 1. So again for 1 he will get 7, 7 1s are 7, 7 4s are 28, 7 2s are 14, 7 8s are 56, 7 5s are 35 and 7 7s are 49. Again he will get 1. So what we are getting basically here is 0.142857 bar. Now carefully observe this division. Here when you are dividing with 1, again 1 came. Until then we have does the division, and after that we stopped division and we wrote 0.142857 bar. Now for example, now if you get the question like what is 2 by 7, so you have to divide 2 with 7. So here if you carefully observe, where is 2? In this line here it is 1, okay, it is 3, okay, here it is 2. So when 2 came, where did we start? If you carefully observe, when 2 came we started with 7 2s are 14. So 0 point, after that we get 2, 7 2s are 14. Then again 6 will come, 7 8s are 56. Then again 40 will come, 7 5s are 35. Then again 49 will come, means 50 will come. Then 7 7s are 49. Again 1 will come, 7 1s are 7 we write. And then 7 1s are 7, 3 will be left out. Then again we get 4. Then 7 4s are 28 we write, and again what we will get? 2. You just do the division and check. So here we get 0.28571. For if you carefully observe, these are the numbers 2 8 5 7, then 1 here and 4 here. Now instead of 2 by 7, if we get 3 by 7, what happens? So where is 3? 3 is here. So first what we have to do, 7 4s are 28. So 0.4 onwards we start. So 4 onwards, what are the things here? Just observe. 4 2 8 5 7. Then what will come? 1. Similarly 4 by 7. Is there any 4 here? Yes, 4 by 7. Again then similarly 6 by 7. 5 by 7. Like this, if you do one, you can write others also this way. So based on this, you have a question in your exercise also. Just do that sum. Now coming to our exercise, let us see the first Roman here. In the exercise, first Roman, if you have textbook, it's okay. If you don't have also, it's not a problem. 36 by 100. So since it is a decimal, denominator is in 100, multiple of 10, it is a decimal fraction. So simply 36 by 100, what we write? 0.36, decimal before 2 places, since 2 zeros are there. Similarly 1 by 11, you do the division, there will be some repeating pattern. 4 and 1 by 8, convert it into a general fraction, regular fraction, and then you divide it, then since denominator is 8, you guess, yes, your guess is right, denominator is 8, you will get a terminating decimal. Next 3 by 13 you divide and write, there will be a non-terminating repeating. Here also non-terminating repeating, and here since decimals 2 zeros are there, 4 into 100 you divide it with 4 first, you will get a terminating decimal, and 2 zeros means again 2 places terminating decimal. So finally what is expected in this chapter is, in this first Roman is, You will have to do the division. You have to write in decimal form, and you have to write also what kind of decimal. For example, if you are writing the first question, 36 by 100 is equal to 0.36. What is the time? It is terminating. Like this you will write terminating decimal. The same way, 1 by 11, just divide this 1 with 11, decimal 0, 0.11, again decimal will be less, 0.0, then 100, 11 nines are 99. So what is left out? 1. Again you need a, since decimal is there, you can take a 0, but it will be less than 11. So you have to take one more 0 here and 100. Again 11 nines are 99. So what did we observe? 0.090909 are come. So we simply write 0.09 bar. And along with that we have to write non-terminating repeating. Since bar is there, we have to write non-terminating repeating decimal. So in this Roman, you either get a terminating decimal or non-terminating repeating decimal. So after this division, you will have to mention this also. So that is about first Roman. And second Roman questions we have already discussed. We have already discussed this. And third Roman questions are very funny, and we will be learning them now. Now how do we learn them? Let us see. Now as you have seen, 1 by 11 you have simply written as 0.09 bar. Because you know the division, you have been doing it from ages. So you know it and you did it. But what if they give you 0.09 bar and ask you to find the fraction from which it has come? So how do we find it? That questions only we write 0.09 bar in the form of P by Q. Let us try to solve them. So this is a very good new process that you are going to learn here. Very interesting. We will assume the given fraction as x. 0.09 bar, no? 0.090909, so on. Let us assume this is x. Okay. Now here very important point. Since below decimal, under the decimal, we have how many places? Under the bar, 2 places. Two numbers are repeating. 2 digits are repeating. Since 2 digits are repeating, we have to multiply it with 100. If 1 digit is repeating, we will multiply it with 10. If it is 3 digits, then 1000. So here in our case, it is 2 digits. So we will multiply it with 100. So multiply on both sides with 100. So 100 into x, 100x is equal to, if you multiply this one with 100 on right side, what happens? 2 places are there. So 2 places, the decimal moves 2 places. That is 09.090909, so on. Now here we will take the x value once again. X is equal to 0 decimal 090909, so on. Now what we are doing is, now we are doing a small subtraction. So here on the left side, 100x minus 1x, how much? 99x. On right side, when you are subtracting, 9 minus 9, 0 minus 0, 9 minus 9, 0 minus 0, 9, 9, 9. So what is left out? 9 minus 0, 9. So what we are getting here is 99x is equal to 9. So x is equal to 9 by 99. So 9 ones are 9, 11s are. Did we get our question 1 by 11 once again? So this is the process. Once again, let me repeat the process with another example. So this time we take, let us 1 by 3. 1 by 3 we know 0.3333, that's so on. So this we are writing as 0.3 bar. Now the question is, write 0.3 bar in the form of P by Q. So what is the first step? We have to assume it is 0. X is equal to, let x is equal to 0.3333, so on. Now under this bar we have only 1 digit, so you have to multiply with 10. Very good. Since 10 wala number 10 se multiply karenge. 10 into x, 10x is equal to, here also with 10 if you multiply, decimal moves just one place, that is 3.3333, so on. Now another, again we will take the value of x, 0.3333, so on. Now when you subtract, here 10 minus 1, 9x is equal to, on the right side 3 solve will get minus na, cancel ho jayega, 3 minus 0, 3. So 9x is equal to 3, x is equal to 3 by 9. 3 ones are 3 3s are. So did we get the 1 by 3 that we have started with? So this is how we write a number in p by q form. Now, so you can express all these numbers. Here under the bar only one digit is there, so you multiply with 10. Here it is two digits. Here also 0.47 bar. You observe carefully, this is a little bit different. This question is given to just make you confused. 0.47 bar, only 7 is repeating. So here x is equal to 0.47777. Now under the bar only one digit is there, so you multiply it with 10 and then minus x. 9x is equal to whatever is the system, you will go along with that. And after that you have 0.001 bar, that also you can do. And now coming to the next question, express 0.9999. This also you do. It's a very interesting question. Then next, what is the maximum number of digits in the repeating block of digits in the expansion of 1 by 17? Perform what can be the maximum number, it's asking. For any digits, for any prime number or anything, maximum digits is, because 1 may come, 2, 3, 4, 5, 6, 7, 8, 9 may come. While dividing, like you are dividing 1 with 7, it started with 1. Again the question somewhere 2 may come, again 3 may come, or 4 may come, 5 may come, 6 may come, 7 may come, or 8, 9 may come. Again, if other than that any other number comes, the repeating will be, it will start repeating. So the maximum number we can get is only, the maximum number we can get is only 9. So 1 by 17 block, maximum can be 9. It may be 9 or may not be 9. All numbers, 9 digits may not repeat. So you just try, you just do it and check. And other questions also you try to do. And in 8th question, let us see, find 3 different irrational numbers between irrational numbers they are asking, that is non-terminating, non-repeating digits. Non-terminating, first you convert 5 by 7 into decimal, and then you convert 9 by 11 into decimal. In between these two decimals, you write any decimal which is infinitely extending without any pattern. So those will be our required. We required irrational numbers, rational numbers, and classify the following numbers as rational and irrational. जो rational है rational लिखेंगे, जो irrational है irrational लिखेंगे. Okay. So this is how you are supposed to do the third exercise. All the best. And after doing this sum, again we will meet. Bye.